Okay, everybody. Today we will learn the software design analysis. In this software structure analysis or system design analysis, in this analysis part, the structure analysis means that actually it captures the detailed structure of the system as provided by the user and as it is written into the SRS. So in the requirement specification, we have learned what is SRS, and all the user requirement are written into this SRS, and this SRS is the input of the next state, that is structured analysis. And in this structure details or structure analysis, the purpose of structure design is to define the structure of the solution that is suitable for implementation in some programming language. So whatever is written, whatever the user requirements have been written into this SRS, that we have to convert into some structural part, into some graphical part, that as it is a very important way to a very good way to define your views into others. The graphical part is very much helpful to understand the rather than better than the structured part, English like structured part, whatever is written into the SRS. So those structure are to be analyzed into the from the SRS and are to be managed through some graphical notation, that whatever the developers will develop, they can easily understand what will be the structure and what will be the, what they should develop. Okay. So the first structural analysis is ERD, Entity Relationship Diagram. I think you have learned this into the database management system. So I will go through this. I will do not show the too much details. I will just give the how the ER diagram will be developed, and then I will give you some problems, and you will. I think you can easily solve that problems after this. Okay. So first ER diagram. ER means entity relationship data model. ER means entity relationship. It views the real world as a set of basic objective entities and relationships among those objects. So in the SRS, it was written like English like language, whatever the user requirement was, and then now we are modeling those user requirements into some structural part, that is called ER diagram, by some using some graphical notation. So it is intended primarily for the database design process by allowing the specification of an enterprise system. This represents the overall logical structure of the database. So through the in the data into the database, this type of structure will be present, and that is diagrammed here into this entity relationship diagram model. An entity is an object that exists and is distinguishable from the other objects. So what is an entity? It is an object that exists and is distinguishable from other objects. For instance, Amit, roll number 12, is an entity, as he can be uniquely identified as one particular person in the universe. So Amit, roll 12, is a single person. You can uniquely identify this Amit from any other Amits into your class. Okay, and so Amit is an entity here. An entity may be concerned a person, may be concerned a book, or for example, or something abstract like holiday or a disease or a concept. So this may be an entity. A person, you can store the height of the person, the complexion of the person, the etc., etc., and the address of a person. For a book, the number of the book, the name of the book, the author of the book, etc. You can store this type of information for this book entity. Or in some terms, the abstract like holiday. The holiday is the in which date the holiday is, why this holiday is. So this is the data for you can store for this holiday abstract. In case of disease, what is the name of the disease, what is the symptoms of this disease, etc., etc. An entity set is a set of entities of the same type. So all persons having an account in a bank is an entity, because all those persons who have an account in their bank have the same characteristic, have the same attributes. That's why those group of persons or those group of person entity we can call the set of entities. Entity sets need not be disjoint. For example, the entity set student, all students in an university. Student means all student in an university. And the entity set professor, all professors in an university, may have members in common. Okay, may have members in, that is, a computer science professor might take a class in anthropology. Maybe it is possible, because if in the anthropology department, if there is a class of C language, then a computer professor can go into the anthropology class. So an entity set need not to be disjoint. It may be disjoint, or but it is not mandatory necessities. So an entity is represented by a set of attributes like name, SSN, phone number, customer, entity, etc., etc. So these are the attributes which are associated with those entities, like student. Okay, ERD. We can express the overall logical structure of a database graphically with an entity diagram. Its its components are rectangles represent entity sets, rectangle represents entity sets, ellipse represents attributes, links or linking attributes to entity sets, and entity set to represent the sets. So this is a rectangle, so it represents the entity set, it represents the entity sets. So rectangle represents the entity sets. Here the entity is students. The set name of the entity is students. That's why we have made this rectangle. Okay. Now ellipse represents the attributes. These are the attributes. Name is the attributes of this entity. Role is another attribute of this entity. Street is another entity of this attributes, and city is another entity of these attributes. So these are the entities which are associated with this. These are the attributes which are associated with these entity sets, and these lines are we call link, which links these attribute sets with the entity sets. Okay, so in this ER diagram we represent these attributes and entities such a way. Next, diamonds represents relationship sets. Diamonds represents relationship sets. So here this is the relationship diamond advised by. So student is an entity and professor is an entity. So what is the relation between student and professor? The relation is professor advised to the students and students are advised by the professor. Okay, students are advised by the professor or professor advised to students. So this is the relation, and these relation are linked with these two entity set, students and professor, and they are linked with this link line. And student entity has its own attributes, professor entity has its own attributes, and this relationship has a new attribute that is called since when the professor is related or advised to the students, or students are advised by the professor since when. Okay, so this is called the relationship. It represented by the diamond shape. The key constraint or mapping cardinalities. We can also use arrows to indicate keys constraints. Often simple referred to as constraint. Some people use the term mapping cardinality to refer to the key constraint. So this is called key constraint mapping cardinality. Here we are using the term key constraint, or in case of exam it maybe comes by the mapping cardinality, in the name of mapping cardinality. Suppose the university has the following rules. A professor is allowed to advise at most one student. A professor is allowed to advise at most one student. However, two or more professors are allowed to advise the same students. So more number of professors may be more than one who allows a single student. That is, Dr. Keogh and Dr. Lonardi both advise the student Isaac. So in this example of a many to one constraint, many professor to one student, that is, many professor can advise a one single student. We can represent this with an arrow as shown below. This is the arrow. So that means many to one. So the cardinality is here many, and here is it is one. Okay, the key so we can show this by this arrow sign. We can show this symbol by this arrow symbol. So another key constraint, there are four possible key constraints that express the number of entities to which another entity to be associated via the relationship. So entity is associated to the via the relationship, and this type of key constraint, there are four key constraints possible. For binary relationship sets between entity set A and B, the mapping cardinality must be one of these four. Okay. So first one is one to one. An entity in A is associated with at most one entity in B. At most one entity in B. And an entity in B is associated with at most one entity in B. So this is called one to one. A is associated with at most one entity in B, and B entity is associated with at most one entity, at most one entity in A. So that is called one to one. Okay, one to many. An entity in A is associated with any number in B. An entity A is associated with any number of B. An entity in B is associated with at most one entity in B. An entity in A. That means A in actor A entity may be associated with any number of B, and A, B is associated with at most one entity in A. This is called one to many. One to many. Next is many to one. An entity in A is associated with at most one entity in B. তাহলে একটা এন্টিটি একটা বি এর সঙ্গে কন্টাক্ট করতে পারবে। an entity in B is associated with any number of A. An entity of B is associated with any number of A. This is called many to one. But an entity of A is associated with at most one entity in B. Next is many to many. Entities in A and B are associated with any number from each other. That means many entity of A can associate it with many entity of B. The appropriate key constant for a particular relationship sets depends on the real world being modeled. So first one is one to one. An entity in A is associated with at most one entity in B, and an entity in B is associated with at most one entity in A. A man may be married to at most one woman. A man may be married with at most one woman. An woman may be married with at most one man. Both men and women can be unmarried. So here we are showing that there are four men and four women. Two men are unmarried, sorry, one man is unmarried and one woman is unmarried. It is possible into the entity set, one woman or one man is unmarried. But in this entity set, you have to look that one entity from this side is associated with one entity, only one entity of this side. If it is, then it is a one to one key constraint or cardinality. So here we have represented this by this two arrow sign in the both of the side. Here one to one. Man is married to one woman. A man is married to one woman. Others are same. So this is the relationship and how to show their represent this relationship in ER diagram. one to many. An entity A is associated with any number of B. An entity A is associated with any number of B. Here the first entity is associated with any number of B identities. An woman may be mother of many children. An woman may be mother of many children. Or a person may have at most one mother. A person, that means a children may have at most one mother. Okay, so here also there may be some ideal entities which have no mother or no son in the list available. So the women's club and low IQ club, that is the person is related, the is mother of relationship. So here one woman is one may be associated with many number of low IQ club members. Okay, that's why it is many to one, many to one. Sorry, one to many, left to right, one to many. Women's club, one woman is associated with many child. Next relationship is many to one. An entity A is associated with at most one entity in B. An entity B is associated with any number of A. B is associated with any number of A. Many people can born in a country, the example, but any individual is born in at most one country. It is many people can born into a single country, but in a single country is associated, but the individual is born at most one country. So here is the bowling club and here is the country. So bowling club members are associated with a single country, but in a country there may be many bowling club members. Okay, so the relationship of one relationship is here. It is associated by this sign, and here in this it is a many relationship. So the total key constraint is called many to one relationship. Many to one relationship. Okay, and last one is many to many. Entities in A and B are associated with any number from each other. Here the relationship name is the classmate. So these entities, these girls have a classmate with a single boy. These girls are the classmate of single boy. Here, this set of boys are classmate of these two girls. Okay, so in this relationship, there is no foundation of association. That means many entities of set A may be associated with a set of B, or in the vice versa, a set of B, many associates of entities of B may be associated with many associates of with many entities of the set of A. So this relationship is called many to many, and we represents without any symbol, without any arrow symbol, giving to saying that this is a many relationship. So in case of many relationships, there is no symbol, no arrow sign, and in case of one relationship, there is a arrow sign. Okay. So these are the four key constraints among the relationship of the entity sets. Suppose we want to build a database for the Springfield Christian Married Persons Association. In this case, everyone must be married in database. Terms their participation must be total. That means in the previous case that allows the unmarried people to say to have partial participation. This is called partial participation. That means he is not associated with this as entities of B is not associated with the any entity set of A. Also, these entities of A is not associated with any entity of B. So this is called partial participation. So the partial participation, that is one-to-one relationship, was like this. But here we had saying that this type of ideal entities should not be present into an entity. So all the participants, any participant into this entity set are to be should to be associated with any entities of this group B relationships, group B entity sets. So we can use bold lines and arrow lines independency to indicate the key constraint independently for each other to create an expressive language of possibilities. So here we have used a bold line. This bold line means this is a total relationship. That means there is no man who is sitting ideal and who has not married to any person, or there is no person name who did not have who did not have associated with a single woman. So this was the total participation. This is called the total participation. Entity sets can be related to themselves. Suppose that we want to pair a mature student with a novice student. We want to pair a mature student with a novice student. We can annotate the roles played by the entities in this case. So we can annotate the roles. That means here a single entity is related with itself. Here the single entity student is related with those entity which is also present into the student entity. A student is related with those student who is also a member of the same set, same entity set. So this type of this is represented as this is a student entity, and this is the relationship name is study partner, and this is mature, this is novice. So student mature student is study partner is a novice student, and this is the entity attribute. This is the attributes of the study partner, of which subject they are associated with. Okay, so this type of association is also present into the ER diagram. What is the correct choice of attributes to represent data? What is the correct choice of attributes to represent the data? Using three field, day, month and year are probably the best solution. है ना? If we use the date of birth is DOB, this is one choice, and another choice is you break down this date of birth and create day, month and year. So if we create this date DOB, so here the date of birth is written as 12/11/1986 এরকম. So this is called complex attribute. This is called complex attributes. But if we divide this into day, month and year, then the 12 will be stored here, 11 will be stored here, and 1986 will be stored here. So you cannot further modify these attributes. So that's why this type of attributes are called atomic attributes. So that's why it is called atomic attributes. Those attributes you cannot divide further. And if you can divide an attribute, then it is called complex attributes. An attribute is called derived attribute whose value is calculated or derived from other attributes. Obviously, in the previous case, the complex attributes should not be present into your database. It is better that you should store the atomic attributes into your database. An attribute is called derived attributes whose value is calculated or derived from other attributes. So an attribute is called derived attributes whose value is calculated or derived from other attributes. It represented by dashed overall. The attribute is represented by the dashed line. Person's age is derived attribute. Age is a derived attribute over the time and can be derived from any other attribute. That means if you stored the data in 1st January 1990, then this age should be calculated from the date of birth, from this date minus date of birth, and that value are to be stored into this age. And the double line represents the multi-value attribute. Multi-value means if there are, it is possible that if a student may have multiple connections of mobiles or phone numbers. Then he have multiple phone numbers. One is 9738, another is 9862, another is 8771. So these three are to be stored into a single phone attribute, under a single phone attribute. That's why it is called that multi-value attribute. Multi-value attributes we represent by double ellipse, and the derived attribute is called derived attribute we represent here by the dashed ellipse. And derived attributes are those attributes which are calculated from the system data, from which are calculated value from other attributes. The key constraint. The super key is a set of one or more attributes which taken collectively. I think you have everyone should have this idea of key. I just going through this as you have done this into the DBMS class. And a super key is a set of one or more attributes which taken collectively allows us to identify uniquely an entity is an entity set. For example, in the entity set, student, here is the student's entity set, name and roll number. This name and roll number is a super key as a combination collectively. Okay. Note that name alone is not as a two students, as two students have the same name. Student name alone is not a key because more than one students have the same name. More than one student have the same name. That's why that name is not possible to be a key constraint. And a super key may contain extraneous attributes, and we are often interested in the smallest super key. A super key for which no subject is a super key, no subset is a super key is called candidate key. If it is a super key and there is no subset of that super key which is also a super key, so then it is called that candidate key. Suppose we are doing a student database and we are giving the name and roll number. So roll number 1, 2, 3, 4, such a way, name A, B, C, D. Okay. So student, in case here name and roll number is collectively as a super key, and the roll number is single as a single, that is the subset of the previous super key, is also a super key. So that's why this type of key, this role is called candidate key, because this is the minimal super key. We cannot divide, there is no subset of this super key. We can see that name role is a super key. In this example, role is a candidate key as it is a minimal and unique and uniquely identifies a student entity set. Here the number is became same. This number should be different. This is a printing mistake, typo error. ERD diagram. A primary key is a candidate key. Primary key is a candidate key. There may be more than one candidate key. In a table, there should be more than one candidate key. Chosen by the primary key has been chosen by the database designer to identify the entities in an entity set. So primary key has been chosen by the database designer. So the primary key is denoted by an ER diagram by underline. An entity has a primary key is called a strong entity. If an entity has a primary key, then this entity set is called the strong entity set. So in this example, here the attributes are make, model, owner, state, license number, and VIN number. So make, model, owner, state, license, VIN is a super key. As a whole, the thing is a super key. And there are another super key which are subset of this super key are state, license, VIN, and make, model, owner. Make model owner is not a super key because these three things may be same. It is possible that it is same, and it is not a super key. So state license is a candidate key. Another candidate key is a state license, which is a also minimal super key of this super key. State license and VIN. VIN is a candidate key. If we minimal this state license, we can get only VIN. So VIN is a minimal super key, the most minimal super key of the other keys. So VIN is logical choice of a primary for primary key. So as this is the candidate, it is the candidate key, the smallest candidate key. Here, the primary key has been chosen by the database designer as VIN because the license number may be repeated. An entity set that does not possess sufficient attributes to form a primary key is called a weak entity. Think about this. This is the important part of your diagram, the weak entity. If an entity set which has not sufficient attributes to form a primary key is called weak entities. In this example below, there are two different sections of C++ being offered. Here are two different sections C++ has been offered, and the number of this code is CS2, CS1 to CS12. So there is no sufficient attributes in this table which will clearly make a candidate key or the primary key of this table. So this table should not be a strong entity set. This should not be a strong entity set. Name and number is not a super key, and therefore course is a weak entity. That's why it is a weak entity. In order to able to uniquely refer to an item in a weak entity set, we must consider some or all of its attributes in conjunction of some strong entity's primary key. Clear? So as this is a weak entity, course is a weak entity, so we have to associate this course with some strong entity to make this weak entity as strong. The entity whose primary key is being used is called identifying owner. The entity whose primary key is identifying owner, whose primary key is being used to call the identifying owner. Which entity's primary key is used to make the strong of this course entity is called identifying or owner entity set. For this to work, two conditions must be met. One is that weak entity set must have total participation of the relationship. Weak entity set must have the total participation of the relationship in the relationship. The identifying owner and the weak entity set must participate in is as a one of many relationship. The identify so this type of relationship is called identifying, and this is the weak entity set, and whatever the relationship which relates this identifying or owner entity set with the weak entity set are called identifying relationship, and weak entity is denoted by the double layer circuits, double layer rectangles, and weak relationship as said by the double layer uh, diamond shape. Okay, so this is called identifying relation, this is identifying owner, this is weak entity, and obviously the primary key which we can denote that this is the primary key, may be denote which is not actually the primary key, are the name and number relationship. Number should also be, and this type of signs, dashed lines, indicates that in through this weak entity set these are the candidate keys, though these are not strong enough to make this entity set strong. It is possible to have higher order relationships, including ternary relationships. That means whatever relationship we have read till now, it was the binary relationship, and now it comes the ternary relationships. That means the relationship, in case of relationship, he should made include in case of this type of relationship, the relations are attached with more than which as it is ternary, with three entity set: employee, job, and branch. Here it is employee, job, and branch. Consider the following example as describe the fact that the employee at a bank work in one or more bank branches and have one or more job description. So here the employee have one or more job description and it has one or more branch. So employee is related here, employee is related with the job and employee is also related with the branch. Employee is also related with the branch. This type of relationship is called ternary relationship. Sometimes you have a choice of a single ternary relationship or two binary relationship. And that means sometimes you may change this ternary relationship into two binary relations. This is one binary relationship and this is one binary relationship. The fact is, every ternary relationship can be converted into a set of binary relationships. So here, females are associated with males and as well as students. So here, the females are associated with students, and students are also associated with male. So by transitively, females are also associated with males, or the students are related with females and males, father of and mother of. Aggregation. Consider this ER diagram which we have seen before. We need to add to it to reflect that managers manages the various tasks performed by an employee at a branch. If we like to check the which employee are come from which branch, then we will check the relationship employees works on branch. Okay. If we like that which employee are doing which job, then this is another type of relationship available here. So the relationships works on and manages the represent overall information. This is the relationship. Every manager manages relationship corresponds to works on relationship. So managers manages the works on. There should be a manager relationship, which and the manager attribute. So this manager attribute should related to the employee, should related with the branch, should related with the job. So, however, this type of architecture is not easily understandable to our employees, and it may be a hectic process, and the process becomes so complex. So, we cannot discard this works on relationship because it also relates this employee, job, and branch. So there are one, two, three, four attributes and four entities and two relationships. So we solved this type of problem into the aggregation. We can eliminate the redundancy via aggregation. How relationships between relationships, it allows relationships between relationships. The aggregation allows relationships between relationships. Abstraction of relationship into a new entity. So here, this relationship we have in the previous, and with this relationship, we are attaching another relationship that is called managers and manager. Okay. An employee works on a particular job at a particular branch. Without introducing the redundancy, the new diagram we have to made, and an employee branch job combination may have an associate manager. Okay. So if we found that who is the manager of this employee, you can goes to the works on through the managers, you can get the managers. If you like to the that this manager is works in which branch, then manager manages works on and then branch. Okay. Specialization. The top-down design process, we designed subgrouping within an entity set that are distinctive from other entities in the set. Actually, these subgroupings becomes lower-level entity sets that have attributes or participate in relationships that do not apply to the higher-level entity set. Okay, depicted by a triangle component levels. I is a that is a person. Customer is a person. Attribute inheritance. A lower level entity set inherits all the attributes and relationship participation on the higher level entity set to which it is linked. So here we have made this. This is a top-down approach. We made that person entity. A person is an employee and is a customer also. So we divide this person into is a relationship through the is a relationship. That means person is specialized into employee and customer. So all the attributes which are available in the person are also into the relationship employee. It actually derives these attributes from the person, but an employee have a new own attribute that is called salary, which is only associated with this employee, not all the persons. In case of customer, he or she has a credit rating, which may not be necessary in case of person, because all person may not have any may not are the customer of this bank. Okay. An employee we have divided into three types: officer, tailor, and secretary. In case of an officer, he has an office number. In case of a tailor, he has a station number in hour worked, and in case of secretary, he has a hours worked. Okay, so a person had to be specialized into three categories, that is officer, tailor, and secretary. Officer have its own entity, own attribute. Tailor and secretary, those three have all its own attribute set. So they are specialized from the a tailor is a specialized from the employee, and employee is specialized from the person. Generalization. A bottom-up design process combines a number of entity sets that share the same features into a higher level entity set. Specialization and generalization are simply inversions of each other. They are represented in an ear diagram in the same way. The terms specializations and generalizations are used interchangeably. So generalization is a bottom-up design. Specialization was a up to top-down approach. And generalization combine a number of entity that shares the same features into a higher level entity, but specialization subgroups the higher level entity into some special case, into some special situation who have all its own attributes. Specialization and generalization are simply inversions of each other. They are represented in ear diagram in the same way. So in the ear diagram, specialization, generalization are to be done in same way. The term specialization and generalization are used interchangeably. Okay.